In this nugget, you and I get to take a look at IPv4 multicast under the microscope with Wireshark. Let's begin. One of the benefits of multicast is that we're sending packets that are destined to a group of devices as opposed to unicast, which is going to a single device. So for example, if we had some content that we wanted to send to Bob, Lois, Susan, and Kevin, we could have all of those computers join this multicast group, and then the multicast server could send one packet, and that single packet could then be processed by Bob, Lois, Susan, and Kevin, who are all interested in that group content. At the same time, other devices like Karen and John, who are not interested in that content, don't have to pay attention to those frames and packets as they come in, because John and Karen's computers have no interest in that multicast content for that group. A multicast IP address has a destination that begins with 224 all the way through 239, and that's a special Class D address range. And on Ethernet networks, because we have to deliver frames based on layer 2 Ethernet addresses, a multicast layer 2 address is created, and the way it's done, it uses the first 6 characters. In a layer 2 Ethernet address, there's 48 bits, or 12 hexadecimal characters. The first half of that is always going to be 01005E. And for the second half of the layer 2 MAC address that's going to correspond to this multicast IP layer 3 group address, we take the last 23 bits of the IP group address, and those get dropped down as part of the formula in creating the corresponding layer 2 address. Now, there's a fascinating story about why we don't get to use the full 24 bits. And if you'd like more of the details regarding how that works and why that happened, regarding the math involved, I would recommend you check out my YouTube video called Multicast-Convert IP to MAC Address. And it goes through the details step by step of converting the layer 3 IP group address to the corresponding layer 2 MAC address for that multicast group. In the IP version 4 protocol suite, there's lots of protocols that use multicast, including routing protocols such as OSPF and EIGRP. And the benefit of that is if we have 5 or 6 routers on a network segment, a hello message could be sent out by router 1, for example, and because it's multicast and all the other routers are paying attention to that multicast group and its corresponding layer 2 address, the single multicast packet sent by R1 could be seen by R2, R3, R4, and R5. Other uses for IPv4 multicast are streaming applications. For example, maybe we have a multicast server and we want to stream out this content to a specific multicast group, and then any devices that want to tune in and pay attention to that group can go ahead and do so, and that way we're not bothering the other devices on the network that perhaps are not interested in that group. And in a fully functional multicast network, we would also have configured our routers to properly forward that multicast traffic and route that multicast traffic so that the content can be delivered to the hosts and devices that are interested in that multicast group who want to see that content. So what you and I get to do, we're going to lab up a simple environment and then do a Wireshark capture to take a look at the layer 3 and layer 2 addresses involved in multicast on an Ethernet network. So let's use Wireshark version 1.x to go ahead and create our topology. I'm not worried about saving this one. It's going to be really simple. We'll simply grab 2 routers. We'll have router 1 and router 2. We'll use the link/connector tool to go ahead and connect them together. I'm going to use Ethernet 1/0 on both sides. Turn off the link tool and then go ahead and add the labels. And again, for more details about the basics of working with GNS3, you can check out our GNS3 nuggets as part of the GNS3 course. So now let's go ahead and start up these 2 routers by clicking on the Start icon. And then we'll open up consoles to each one of them. I'll right-click on R1, select console, and while we're at it, we'll go ahead and bring up a console for R2 as well. Fantastic. So with both of them up, let's go ahead and do R1 first. We're simply going to configure a basic IP address on its Ethernet 1/0 interface and bring that interface up. So we'll go into configuration mode, specifically for interface E1/0, and we'll issue the command no shutdown. Now that that interface is up, this next step is totally optional, but I'm going to use it for clarity inside of our packet captures with Wireshark. I'm going to manually specify the MAC address that I want to use on this Ethernet interface. That way when we see it, we'll know, oh, that's the MAC address for R1. So out of the 12 hexadecimal characters, the first 4 are zeros, and then I have 01010101 for R1's Ethernet 1/0. And then we'll give it a beautiful IP address. We're going to give it 10.0.0.1 with a 24-bit mask. Next, let's make a road trip over to R2. On R2, we'll do a similar treatment in configuration mode for interface E1/0. We'll do a no shutdown to bring it up. And let's manually assign a MAC address here as well. Not the same MAC address, because that would be a problem on the same segment with R1, but we'll give it a MAC address with 0000 and then 02020202. So when we see that, we'll know, oh, that's the MAC address for the Ethernet 1/0 interface on R2. We've also assigned an IP address of 10.0.0.2 to that same interface. One additional thing that I'd like to do together with you on this interface is join a multicast group. And that way, if we send packets or ping to that multicast group, this router will go ahead and say, wow, I'm interested in that, and that will allow this router to reply to it. So to join a multicast group on an interface, we're going to use the command IP IGMP join-group, and I'm going to join this specific multicast group of 224.65.254.9. So as a sanity check, let's go to R1 just for a moment. Let's verify that we can ping the address of 10.0.0.2. And our first packet got consumed by ARP, but if we do that again, we should have a nice clean 5 out of 5 return. So no multicast is involved yet because we haven't sent any multicast content. We don't have any routing protocols running. And one simple way to generate multicast content is to ping a multicast group address. And poof, that device who's generating that ping to that multicast group address is acting effectively as a multicast server pumping out content into the network. So let's go ahead and capture that. We'll go back to GNS3 for a moment. We'll right click on this link between R1 and R2. We'll say start capture. It doesn't really matter which of these two interfaces we choose. They're both going to see that same traffic. So we'll go ahead and choose R1 port Ethernet 1/0 and click on OK. That's going to fire off Wireshark, which is now running. We'll set that in the background just for a moment. And let's generate some multicast traffic. So let's do a ping to 224.65.254.9. That is the multicast group that R2 joined, and as a result, we should get a response back from R2, which processed that packet, opened it up, saw it was a ping request, and it replied back to us. The reply back is going to be unicast directly back to R1, but the initial ping request was sent to the destination multicast group. So let's bring back our protocol analyzer. I'll click on stop. One interesting note regarding Wireshark is that it has a database built in regarding the first 24 bits or 6 characters of a MAC address and who those are registered to. And based on my hard coding of those MAC addresses on R1 and R2, Wireshark's database has those assigned to Xerox, and that's why it's doing me the courtesy of showing me Xerox regarding those addresses. But I digress. What we want to do is we want to take a look at this packet right here, which is packet number 13. If we don't need to see the details in binary or in hex at the very bottom, we can remove that by going to View and then deselecting packet bytes, and it will remove that bottom pane for us. So with packet 13 selected, if we expand the IP header information, here we have the source address. So the packet was sourced from 10.0.0.1, that's R1's IP address, and the destination address was 224.65.254.9, a multicast group. If we click on the minus sign to close the IPv4 section and we look at the layer 2 Ethernet section, here it has the source MAC address of 0000.0101.0101. That's the hard-coded layer 2 MAC address we configured on R1's interface. And look at this destination MAC address. Here it's got the first 6 characters of 01005E, which represent the first 24 bits in hexadecimal. And then for the back half, if we took this multicast group and we took the last 23 bits, so currently this is in decimal, so if we took it from decimal to binary, and then the last 23 bits from binary back into hex, it would be 41FE09. And if you are interested in the detailed math involved for that calculation, I would once again refer you to that video on YouTube where I go through that in detail. So when R2 received this, it first of all saw the destination MAC address, which corresponded to the multicast group address, which it had joined, and that's the reason R2 began to de-encapsulate that packet and take a look at it. And as it de-encapsulated, it saw the layer 3 destination address, which it had also joined. That caused it to continue to go ahead and de-encapsulate until it saw the ping request, with the source being 10.0.0.1. At which point, R2, being a good citizen, sent an ICMP echo reply, and that can be seen right here in packet number 14. And the reply back is unicast, going from 10.0.0.2, which is R2's address, back to 10.0.0.1. And I'm going to save this capture. It'll be available as part of the Nugget Lab files. And we'll name this IPv4 Ethernet Multicast. In this nugget, we've taken a look at the Layer 3 destination addresses for multicast traffic for IP version 4, and in a Ethernet network, how a Layer 2 address can be created based on the Layer 3 multicast group address. We also identified various applications and protocols that can use multicast with IPv4. Then we labbed it up and we captured that traffic and looked at it on an Ethernet segment. I have had a great time in this nugget. I'm so glad you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing.